Oh, my name is Christine G, and I am going to be going over this problem, and you can look at this to identify it rather than the number on the module problem set. So we have data that represents the total compensation for 12 randomly selected CEOs and the company's stock performance. So here, we've given the data and treating compensation as the explanatory variable X, use technology to determine the estimates of beta naught, which is the slope, which is the y-intercept, and beta sub 1, which is the slope. So we're going to go ahead and use StatCrunch. So here we have the compensation, the different companies, and the stock returns. So I think it should be, did that not work? Oh, here it is. Open in StatCrunch. And then stat, and we want to do the regression, simple linear, and then compensation, and then return. All right, so let's see what our slope is. We can look at it up here in the equation, or we can look at it over here. So the estimate of the slope is 0.11. Let's see how many decimals they want. 3. So 0.113. All right, and then the y-intercept, and that would be, the estimate for that is 48.3. All right, and so assuming that the residuals are normally distributed, test whether a linear relation exists between compensation and stock return at the alpha level of 0.10. And what are the null and alternative hypotheses? And here, what we want to do is look at, this is all about the slope. If the slope is 0, then we do not have a linear relationship. And I talked about this in another video, because if the slope is 0, so then it would be multiplied by x, or the compensation, and we would just have the return always equaling the y-intercept, and it wouldn't change no matter what x was. So here we want to look at beta sub 1 is equal to 0, so that means that the slope is equal to 0. And then the alternative would be it doesn't equal 0, or that there is a linear relationship. Okay, compute the test statistic using technology. Well, that's easy because we have that in our results. So, and again, it's all about the slope. So that test statistic, we round to 2 decimal places, so that would be point, we look under t-stat, 0.06. Let's see if that's right. Okay, and then compute the p-value. So again, we're looking at the slope. It's all about the slope. So wow, this is a huge p-value, 0.957. Then state the appropriate conclusion. Okay, so this p-value is way bigger than our level of significance, which is 0.10. This is much bigger than that. So we're not going to reject. So we don't have something down in the tails where it would be very different from the middles. So here, do not reject. There is sufficient evidence to conclude that a linear relation exists between compensation and stock return. Okay, so if we don't reject, that means the slope equals 0 and that there's not a linear relationship. So we do not reject. There is not sufficient evidence to conclude that a linear relation exists between compensation and stock return. So let's go with that one. Yes. Okay, assuming the residuals are normally distributed, construct a 90% confidence interval for the slope of the true least squares regression line. Okay, so we're just going to go in here and let's go into options and then we can edit. And we're going to be doing the confidence interval, and that's at 90%. Okay. And then the lower bound would be -3. Let me move this over a little bit. -3.5, 2 decimals, okay. -3.5, so this will be 6. So we had to round that up. And then the upper bound is 3.82. Okay, and again, just to clarify that, we were looking at the upper and lower limit for slope. So it's all about the slope when we're doing the hypothesis testing. So based on your results to parts B and C, would you recommend using the least squares regression line to predict the stock return of a company based on the CEO's compensation? Why? What would be a good estimate of the stock return based on the data in the table? So, well, first of all, we did not reject the null, meaning that there is not sufficient evidence to conclude that a linear relation exists. So we would not want to use the linear regression equation. So the regression line could be used to predict the stock return, the test in part B, and the confidence interval. So this is already wrong. So based on the results from part B, the regression line could be used to predict no. Based on the results from parts B and C, the regression line should not be used to predict the stock return. Correct. Now, you'll notice here what we're looking for the confidence interval. If 0 is within this lower and upper bound, which it is, then that would mean that there is not, we would reject and not have a linear relationship. So, okay, indicate that the line should not be used. The results are not conclusive and further analysis of the data is needed. I think that sounds on track. Not be used the mean stock return. Oh yeah, the mean stock return would be a good estimate of the stock return based on the data in the table. Yeah, I think that actually would work. Perfect. All right, well, thanks so much for watching, and please reach out to me anytime if you have questions. Thank you.